Hi guys, hope all of us are doing great. In our first discussion on the concept of real functions that we're going to encounter under the general discussion on various topics in calculus, I've mentioned a range of functions, of course, which we are going to come across, which included the zero function, and specifically I talked about the concept of polynomials, which we discussed in details and tried to give various, of course, a set of polynomials which included a constant function, and then we talked about the linear function, and then I mentioned about the concept of a quadratic function, and then lastly I mentioned on the of polynomials which can be given in terms of a higher degree of n, whereby we had values of n, perhaps 3, 4, etc. So we said that of course these are going to be higher order or higher degrees polynomials which can be given in terms of a cubed or cubic, quartic, etc. So basically we have stressed our discussion on various forms of this specific function. Now today we're going to look at a specific unique set of functions that we refer to as a rational function. Now of course we have discussed about this concept of a rational function in some of our videos which might not be basically or directly related to this, but we said that a rational number can be given in terms of a plus b, where a and b are going to be a set of real numbers, of course, which we have given as such. So can be able to give us a and b is a set of real numbers given as such, whereby b is not equivalent to 0 in this specific case. So numbers which can be expressed in this specific form consist of a set of rational numbers. And in this case, of course, we can be able to extend this one, or we can extend that one into the concept of functions. Now, in our first video, I said that we can give a function in terms, especially of a polynomial, in terms of a general description given as f of x is equivalent to a n x n, and then plus a n minus 1 x n minus 1, and this is going to be a number of terms given in that specific order x, and then raised to power 1 plus a 0 given as such. So this was a general description of what we refer to as a polynomial, and we said that for various terms we're going to have this particular value of n greater than 0, and in this specific case the value of a raised subscript n is not equivalent to 0 given as such, and the various range of coefficients that are going to be formed in this specific order for a, which constitute a not a1, an, are of course going to be a set of real numbers as I mentioned. So this was a general description of a function, and we're going to borrow from this, of course, in coming up with this particular set of functions that we are referred to as rational, which are going to be expressed in this specific format that I've already, of course, given in a summary form. So such functions are going to be defined by the formula that we're going to give us f of x is representing a polynomial over another polynomial given in this particular order. So if we, of course, borrow from this general representation of a polynomial that I've given above, we can express this one in terms of the function of f of x given as a polynomial. So this is going to be given as a n x n x raised to power n plus a n minus 1 x n minus 1, and then this is going to be given as a x plus a 0. So this is going to be actually a continuation, and then we're going to have those two last terms given as such, and we can be able as well to, or we can express this one as well as a fractional. So I said it's going to be given in this specific format by having it using another, of course, polynomial b raised to power m x power m plus b m minus 1 x minus 1 plus that continuation b to power 1 x to power 1 given as such, plus b not given as such. So as we can observe from this specific representation, this is going to be a set of two polynomials which have been given in terms of a fraction. So the coefficients of these respective polynomials for the values of a, just as we had expressed in this one, are going to be a set of real numbers, whereby the value of an and bm are not equivalent to 0 given as such. And we're going to assume that this specific set of numbers for the numerator and the denominator given in this specific format are not going to consist of common factors of degree, as we had said, of course, which are going to be greater than, of course, 1, as we said. So these are going to be basically common factors of degrees which are going to be greater than 1, whereby this is going to apply for the two conditions given as such. Now, I've mentioned the concept of a domain in our first case for the representation of a polynomial, or perhaps the zero function and the polynomial in this specific order. So I said that we're going also to express in this specific set of functions that we refer to as rational numbers, whereby their domains are going to be non-zero zeros of the denominator. So if we consider general case for the representation of a rational function, so I'm going to give just an expression for illustration, whereby we have x over x, the square of x minus 1. So in this specific function, which is an, so let me just give it into this specific format. So we have an expression of fx equivalent to x over the square of x minus 1. So we can express the specific domain for this particular function, which is going to be a real 0 of the denominator, whereby our denominator in this case is going to be, or is just the expression over the square of x minus 1. So for us to find the real zeros of this specific denominator, they're going to consist of a domain of numbers negative or 1 and negative 1, in a sense that if we substitute for these specific numbers, then we're going to obtain this specific range of numbers which are going to consist of a domain over this particular function. So for the rational numbers or the rational functions that we're going to come across in various topics, especially in calculus, we're going to see that they are going to have a set of operation or unique rules which we're going to, of course, be using in solving their specific perhaps unknowns given in this specific order. And there are various individuals who are going to come up with particular rules which we are going to exploit, of course, in finding the values of this specific set of rational numbers. Now, first sense for us was to discuss the particular expression of rational numbers and a set of coefficients which are going to be expressed and their particular conditions which I've already mentioned. Now, in our next discussion, we're going to give them using various examples, perhaps in our evaluation and various other discussions, and then we're going to mention some of the rules which we have explained here. Now, first sense for us to understand is know how we can be able to express a polynomial of this specific function, and then of course the set of numbers which we can be able to, or we can give in terms of rational functions, and of course how these ones are going to appear, as we said, in terms of expressions of such representation that I've given on the board under the broader concept of course, elementary calculus as I had mentioned. So that is it for now, guys. Bye, God bless you. Catch us in our next video.